studied about the data types in NumPy, and even though we get through the data structure, array data structure, how your array data structure is being looking forward, with more oftenly with the different objections and that. Okay, we studied about how to present the data type, how to make your data type as an array to the data structure, how your fully compact list has been given to your data type, and that data type has a count, that has a dimension, that has strides, then data, and that all the stuff has been gonna shift in the memory blocks. Then it was described in your floating array, always are being getting to the float. Whether you mention, if you mention, if you didn't mention any of the data type, it will gonna take a float and automatically default as a float. And what happened, like when we are gonna shift to a type, so type is standardized by the end, it's float, complex, that all are being under the numbers. Okay, we read about the data types in Python about the numbers, list, tuple, dictionary, and it was string. Okay, so these were the data types. But what is the actual implementation of the data types as data structures in a array? So in an array, we're gonna see about the type, count, dimension, and strides in data. Okay. Now what happened when you do this and everything? You have a proper intimation of your view, what the view is. Now there is a memory block. Memory block in the sense like there is a memory storing, and each bit it is 4 bytes. Okay, when it compiling the 3, that is 4 4 4. Here 0 to 1 it is 8, then 1 to 2 it is 12. Okay, in the sense adding of your bytes in the particular section of your block is all the blocks are being given as in structured with the memory block. When we're going to see it about what structure you have been doing, so it is being gonna give you that either you can take it as a 3 by 3 matrix, or because it's possible the 3 and 3 matrix has been possible because you're gonna do it with 0 1 2, and after that 3 4 5. Okay, now what happened when you do this all, these are automatically giving to your sequence. Now sequence, what you decide about the sequence is that whether you are being arranging in a block, whether you are being arranging in a compile. Now see, this is nine elements. Okay, now what you can do, either you can convert it to the 3 3 and 4. Okay, then 4 3 3, then it's 4 3 4 3. Okay, but that will not suitable. It's in the sense like it got a 10, but when you're gonna give it a 3 3 2 or 3 3 5, any of that, it will not get a suitable Python. Then we studied about what a NumPy data type is. Okay, so NumPy data type is categorized into more of the Boolean. Then Boolean is taught as the bool. Then integer has been written as an int. Undersigned, that is just an definitions of your what unit defaults are being there, or what sign data forms are there. Then it's float. Float, we know like it has an always given the double precision, single precision, or the long float is there. Okay. Then complex. Complex means either it is the real part or your imaginary part, but with your that orientation of your precision value, that is 32 bits or it's 64 bits or any of the further precision of that. Then we read about the string, how strings are being written as str or the Unicode. Then we read about what are the objects. Just an objects, we have to represent item in arrays, that are the Python object accusations. Okay. Then record was just for the data structure arbitraries that are being used for initialize your program. with a proper standardization, because without the localization and without the definition, you cannot just move on to write a code and to represent that. And just I'm giving the overview. We read about the memory map. In memory map, for creating the memory map arrays, we need memmap, from buffer, and array constructors. Okay. Now for array constructors, memmap or from buffer, this all are being given as a memory to associate, to subclass, to create, to assign some keywords, buffer keywords in your while you're passing any of your execution of your program. But there is a limitation also in your mapped arrays, that is your file always must be less than 2 JB. Then your file always must be as in bit machines, and your file always and always be allocated to a limited edition of your bytes. Okay. Then the memmap, the structure, how your memmap is being structured and how your memmap is been given. So for memmap, we know like these memmap are always and always going to occur in 3D array. Okay. Now for 3D array, it will be going to as in the structural part. But 3D arrays are also being classified and being divided into more forms. Okay. Now more forms, that is either they can be read, either they can be sliced in the form of X, Y, and Z, or either they can be downsample. Downsample at 4x4. Got it? Now what happened if it's going to be a 4x4? Either it is going to be shifted as an X axis, or with the X, it is a negative X, it is a positive X. Either it is going to be a Y axis, and Y axis, either it is by positive or negative. Z also same. Now downsample means it will take either X and Y both with the X terminal and negative terminal. Okay, now if it's taking the X and positive and negative both, so what happened in the positive and negative both? It will be either taking XY, XZ, YZ, YX. Okay, now ZX or ZY. These are occurring as in 4x4 sample. Now, how they depends upon? Okay, now how it depends either in the memory, either in the memory map, or either in the location of it. Okay. Now, what were the binary operators? We just read about what are binary the operators which help us to assign the value of either A and B or X or Y, any of the two operators to compare with multiplication, with addition, with subtraction, with remainder, with power exponentials, with the denominator, and many more. Okay. Now further we read about the logical operators. So logical operators and comparison operators, we read upon the comparison, that is equals to, is equals to, not equal to, and greater. Then again for greater equal to, less and less equal. In the logical, we read about the logical not, logical and, logical or, logical XOR. But always and always remember one thing, when you have been using these nested loop, or you are being using the loops in a subcategorization, never use a loop in respective to the loop you are being generating. Okay, suppose I am using if else. Okay, now in if else, automatically it has been coming to the else if. Okay, now else if it's there. So I know like if you have been making that loops very wrong, it will be giving you the problems. Okay, like you made a that if then else, then your program doesn't occur in the if and else both. Now you automatically know we're going to shift to the else if. Okay, now if in else if also it is not allowing us, what you will be doing, either you're going to get a for loop, is loop, or is not loop. But if you know like the third, till third only you are not able to occur some of the output of the execution, it is not like the program is not suitable then. Okay, the arrays also this occurs. For the I told you for the arrays, like even the Boolean expression is there for the arrays, for the 1 true and 0 for false. Okay, now what happened when you have an equal values of true? Okay, it is going to be shifted as a true value. Now see, in this example, in a 2-day array, there's 1, 2, 3, 4, and 2, 3, 4, 5. then again 1, 2, 5, 4, then it is 1, 3, 4, 5. Now what happened? How it is being getting us? So complete value of this is being judged to that. 1 is equals to 1. Yes, it's true. 2 is equals to 2. It's true. 3 is not equals to 5. So the boolean is false. Either you can write 1, 1, 0, 1. Okay. In the boolean section, you can write that. And again, for 4 is equals to 4, that is true. Now, if one of the substance of A is equals to B, the value of first interval is being equal or not equal, it is being judged by the execution of first point. Okay, now moving to the second point, that is 2, 3, 4, 5. Is it equals to 1, 3, 4, 5? Let's see. 2 is not equals to 1. It's false. 3 is equals to 3. Then again true. 4 is equals to 4. True. 5 is equals to 5. True. If you don't want to write this true, true, false, you can write 1, 1, 0, 1. Then again 0, 1, 1, 1. Okay, in the boolean, because that is a boolean. The functional, again, if the functional is part of, again, is it equal or greater or what it is, the array definition of that is the false allegations of the function that is being executed. Okay. Now, yesterday we read about the what is the array broadcasting or array array simulations. Okay, so array broadcasting and simulations both are being same. But the difference in simulation is that it will be getting us the output of 1 by 1. But in broadcasting, we have a similar value, but with a structural one. Okay. Now, if we have a similar value with a structural one, we don't have to worry about, because we know we have a value, we have the substance. Now it's finished. Okay. Now we have a matrix. We have a block of 4 into 3. That is 4 rows and 3 columns. Now, in 4 rows and 4 columns, we have 0, 0, 0, then 1, 1, 1, then it is 2 to 2. Okay, it's 4, 3. Now, again, we have to plus out. Okay, now, again, this is the broadcasting of another array. That is also the 4 into 3, that is 4 rows and 4 columns. That is 0, 10, 20, 30. Then again, 0, 10, 20, 30. And again the value is 0, 10, 20, 30. Now we have to add our matrices, or we have to add the rows and columns. Each of the row element is being added by itself, like 0 plus 0. That is 0. Then 1 plus 0, that is 1. Then 2 plus 0, that is 2. Okay. Again, shifting to the next row and the next column in that. 0 plus 10. You can check out now the variation of that. Where the variation is that. 0, 10. It's giving 0. Now, can you just tell me like how it is been doing it? We are being adding the similar of your matrices and element, which is being resulting us with the definitions of equalizations. Okay, now what is equalizations? Suppose these are the variables that is being added at 0, 1, 2, then it is 10, 11, 12, then again 20, 21, 22, and again 30, 31, 32. Okay, is it same to this? And this row is also, all the columns and rows are also same to this. Now, adding all these values, all these rows and columns in one of that, we get the solution of this. 0, 1, 2, adding 0, 0, 1, 0, 2, 0, 0, 1, 2. Again, 0, 10 plus 1 plus 10, then 2 plus 10. That comes to 10, 11, 12. Now, see the variable adding this variable, this column of variable to this column of variable. That is known as stretching. When you are being doing this variable, adding that variable, that is known as stretching. When we are adding column, that is called as stringing. Okay. In the rows, we known as the stretching. In the columns, we known as the stretching. In the columns, we known as the strain. Okay. Now we have the 4 of our rows and 3 of our columns. Now stretching and straining If you need only first one, then you can attain that. If you need only last one, you can attain that. But we have to automatically get the shifting of every part. Okay. Now shifting of every part of that, it is just to remember, like if you are being getting that all the stuff or not. Now, what are the rules? What are the actual rules of broadcasting your arrays? First of all, just remember that all the trailing axes of your both the arrays must be either one or the same size of that. Okay, like if it's the 4x3 column or 4x3 column, like rows and column, another one also be the 4x3. Okay, the trailing axis means this part. The trailing axis rows intermediating to columns. Now, trailing axis always and always be the arrays both to be similar, either must be one or having the same size for broadcasting to occur. Okay. Now, if it doesn't have, it will be getting as the mismatching. Okay. The error will be there, that is mismatching error. Even we have to get the same shape, same size, same value. The different value can be there, but the size and the shape should be same. Now you can see the error in that. We have the 4x3, 4 rows and 3 columns. Again, we have just a 4 rows. Okay, now just similar to that, it will not execute. It will just cross to the program will not be executing. When it comes to the action of the broadcasting, like if the action of your broadcasting there, now you can see the axis. I told you what are the axes. These are the intermediating axis, trailing axis. So if you are accessing the broadcasting actions or a broadcasting access, these all are being given with the name of the syntax, like A. The array of this A is 0, 10, 20, 30. Okay. The A array is, like we name this array as A and we name this array as B. Now B array, that is 0, 1, 2. Okay. Now we need a new axis, new array axis. Now how we will be doing it? Either we're gonna multiply that 0, 0, then 0, 1, 0, 2, multiplying that. Okay. Adding that, sorry. 0, 0 plus 0, 0 plus 1, 0 plus 2. Now again, moving forward to the next row. That 10 plus 0, that is 0. 10 plus 1, that is 11. 10 plus 2, that is 12. Then again moving to the 20 plus 0, 20 plus 1, 20 plus 2. Now we know if the structure that it is the only one row and one column is there. So see, it's just a probability, one row and 3 columns are being there. Okay. Now it is just a configuration, like whether you want or not. Okay, if you want the various objections and that depends upon you. Now, if we are moving to the third row and the first column, that is 0 plus 20 plus 0, that is 20. Again, 20 plus 1, that is 21. Again, 20 plus 2, it is 22. Then again, similarly, 30 plus 0, 30 plus 1, and 30 plus 2. All are being given with a certain axis, and these are the transversal axes. Okay, all the x's are giving us the value of 4 into 3. Okay, it has been giving us the value of 4 into 3, but the value of hiring that is a transversal axis. The transversal axis, that doesn't mean that you are occurring proper agenda or proper definitions. No, if you are being getting that all the exercisations and all the agenda, that depends upon you. Now, if we have to reduce that broadcasting, or we have to reduce the major axis of the reducing the major axis of our broadcasting, or of the multiple arrays of your broadcasting, that means either you are going to apply the syntax that is op.reduce A axis, okay, B axis, any of the axis it is being containing in your array. Okay, is it a multiple array, 3D array, any of it? Okay. And whether it is being greater or smaller, you can reduce it. That there is no problem if you are being not reducing, or there is no subsequent occurring, whether you are being reducing or not. Okay, A multi-dimensional array, the reducing of your x's, that is a x's, b x's, only and only applies to OP. Like OP means like any of your element in the default column or row. Okay. Now this depends upon the x's, which x's is there. Now, if your resulting array has an only and only dimensions of less than a, or what the a is being mentioned by you, that the default value of your x's is 0. Okay, now default value of that x's depends upon the what value you gave to the OP. Okay, suppose if you are being hiring that add dot reduce, okay, or add dot reduce the a section. Now what happened in the array, like we gave the array of a section, that is 60, 64 and 68. Now a section means the first row and first column, full row and full column. Now in this, it will be replacing a column, that is 60, 64 and 68. As we read about, like OP is greater than, if the OP has in less than a, or 1 less than a, that will be getting as the default value of 0. Now it will be like add dot reduce a, we gave the value this. Okay, now it will be shifting to this value, that is 60, 64 and 68, and this is reducing. Okay, again if I have to reduce the a each row, okay, now each row will be reduced in that. If I have to reduce this by 1, this will, all the row will be reduced, and these words will be written as 3, 33, 63, 96. Okay. Now, what happens when we use a Zen of the NumPy? Okay, these are all the features of the NumPy, whether you have to get that or not. Okay, if you have to get that, or if you have to submit that, you have to remember a few of the points. That is, the strided is better than scattering. You don't have to get them when you do the striding of the multiple lines or multiple actions. You don't have to stride that, and your contiguous every striding actions are being contiguous to that. Okay. Third point is that there should be every descriptive data type is being imperative to that. Okay. Fourth, array oriented should be there, or object oriented should be there. Then it is broadcasting should be a greatest idea, because if you are being not using the same of the rows and the columns or adding it, it will give you array. Okay, it will give you error in that. Then again, the vectorization should be explicit loop. Okay, then your size and numeric should be there, and your dimension should be preferred. Now moving forward to the next topic, that is what are pandas in Python. As you can already see, there's a beautiful logo of pandas, and the Python icon is also there, and smallest the pandas is also there. So what is the linkage of that? That is a beautiful icon of the pandas. Now moving forward to the water pandas. So first of all, the pandas is a software library written for a Python programming language for data manipulation and analysis. Python library is always being providing a feature similar to like MATLAB and SAS. Okay, your pandas are being built on your NumPy, your SkyPy, your Matplotlib. And what happens if in a particularly if it offers more of the data structure and operations for manipulations, numerical table are being giving it time for that. Okay, because it is just a free software to release the third party license, and the name is being derived from the term that was basically the panel data. That means that the data sits in that, and that data sets have a multiple time of period to use an observation, or to get the same individual criteria, or to play with that all the phrases of what pandas have. Okay, now what are the key components of your pandas? That is, it has series and it has data frame. Okay, these are the two key components of using pandas, that is series and data frame. Now how we used to get the simplifications of your simplifications of your wranglings. Okay, now we know like the pandas are being been defined by the author, that is that was the Westman guy, and the developer. They are being given a software to the developer community in 2008, 11th of January, and these all details were when they were gave their all the details. So they asked about the raw data. Okay, now what we did about what the raw data, what the process data is, and what is your output data and the storage in that. Okay, now all of this stuff, it is being given to the probably uh, more of the packages cloning. Okay, now all the packages you have been cloning in that, these are being all being written in Python, C, then it was Python and many more. Okay, now when we use a data wrangling, so in data wrangling, first point to read about, like we have to munch that data, we have to prepare that data, we have to clean that data to show that if it's slow, if it has an error in that, or if it's in the time consuming. Okay, if these are the points, if it, because nobody wants, like if we have been working since morning. Okay, nobody needs, like if we put our data or make a data set, we should wait till night for the single data. No, we need the fastest update of the data. Okay, now the fastest update of the data, obviously we need particularly frames for that. Okay, now everyone knows, like already that Python of the data is being taken by the next level of the pandas. So the simplifications of the data wrangling is a must for them. Now how to install your pandas, just write these of the two commands, that is pip install pandas, pip install as pd. Okay, just write these of the two commands for importing or for the installation, that is pip install pandas. Then another one is the pip install pandas as pd. Now what happens when explosive of the panda growth is there? Okay, it is a very good framework of like the releases package of the 2009. What happened, like when the developer Westman guy started working on the pandas in 2008. Okay, so he gave that as an AQR capital management. Okay, what he did, he was given us the data, that was the free refreshed one. Before going to that, he submitted that of the data to a company that was based on the Hughley. Okay, and what happened to the Hughley part, these were the non-charity organization or non-charity in the Hughley. They just shifted that data. That data was very slowest part, and they shifted that data to one of the company as an open source. Okay, so in 2010 when they gave 2009 when they gave the company as an open source package, what they added upon, they added a sponsored package in that, because it should be a flexible, it should be a performance based, it should be the high management team, everything to be that. So that took pandas took a huge growth, an explosive growth to the highest level. Okay, now how it took in the highest level, or how? So IPython were introduced. Like the IPython means that is just simply the hottest Python in your project when you complete that or any of that. And there is a tab completion, there's introspection, there interaction, there is an interactive debugger, the command history, and any of that. Okay, now when you do so, okay, when you design it, when you design your productivity in that, that's what your Python took a huge winning position. Now, now what was the purpose of that? Sorry. Now, what was the, like why the Python pandas module was generated? So we already know that the pandas is basically an open source Python module. We all know that, and you can like just try the packages also of that. It is just an open source Python module. What it has a huge scope, huge of the associations with the computing, the data analysis, or the statistics. And there are many more, like in the statistics, in your analyzing of your data, in your refining your data, in your modeling your data, then the software development of your data. Okay, so it has a huge of a structure. Now, what happened in the Python pandas? It just have a three of the data structure in that. That is data frames. Another one is series, and next one is your pandas or the pandas. So these all are being having just a three part of it. So what happened when you have a library function or you have a library instructors? Okay, now library function just like in the library features. Okay, so these all have to, you have to remember, like it is in series, it is in the data frame, it is a functional opportunity or. While moving to the series, okay, so in your series, so only and only one dimension array is there. Okay, just to create the data in it and like enables the labels in that. There is a lot of, like in series means you are just importing your, well, first of all, the pandas. After that, you are being reshaping it. After that, you are being making that data as in data alignment, then grouping that data and everything. Now, suppose I have import my pandas. Okay, now I have imported my pandas as PD. Again, writing a syntax like my PD series will be as an alphabetic. It should be a list also, as in series also, and alphabet also. Okay, series, list, and alphabet. And how it knows, like it should be in a singular part. Okay, now it will be writing in the, like in our notebooks or like in your data sheets or everything, we just write the word 0, 1, 2, just the serial number. So it will be giving us the serial number, that is 0, 1, 2, 3, 4, 5. Then after that, it will be giving us the value up till that is defined, that is A, B, C, D, E, F. Okay, it is still only A, B, C, D, E, F. Then again, if I wrote the same of the series, but in the list, like here I just wrote the list, but here I am just defining the square brackets as a list. That is 2, 4, 6, 8. These are only 4. But the value always starts from the 0. That because that's the series. So it will be giving us, because just to write upon the labels also as an indexing. So it will be giving us a pre-value of 0, 2, 1, 4, 2, 6, and 3, 8. How does your series work actually? How your values are being given in a series. Series are always and always indexed. Series always have the value which can be selected by the indexing. There is multiple values that can be selected in the multiple indexes. There are multiple ways to do so. If suppose you are being given the series not as a specific one, you can convert that series in specific while writing that series dot arrange. Okay, so series dot arrange, you are being giving that value as in specific part. Now, single values can be selected by the index. Multiple values can also be selected with the multiple indexes. Remember one thing: single with single index, multiple with multiple index. Okay. Now, if you don't have a multiple index and you have a single value, so it is being a problematic to actualizing the various objects, various classes, and that, and various object. Okay. Now, various object, various classes, and various index. Suppose we have a different values and different index also, like the series containing of 2, 4, 6, 8. Then the values and being giving us the 5ACE. 5ACE. Now list, now the series. Now either index will be there, indexing is 5ACE. Indexing are being actually properly as in series. Okay, now it is 5FACE 2, 4, 6, 8. Now I need a value of A. Like in indexing, we used to do like for indexing just for print in the square brackets, then we used to write 4 colon 3, 5 colon 4. Similarly to this, in the pandas, we have the word written as the SA. We have to get the value of S. S is defining the what the series is, and indexing is in front. That's it. And if we need an indexing of that or get the value of S A, the SA value is 4. It is just similar to it. SA, like if I need the value of E8, so E8 is equals to E is equals to 8. Similarly, if I need the two values, two structural values, A and C combining, so it will be giving me the value as that it is A is equals to 4, C is equals to 6. Again, if I attach more of the value, that is F and E also, this all the values are being given the similar path. Multiple values can be selected by multiple index. Single value is being selected by the single index. Okay. What happen if you have a series? Okay, now if your series are being given and your series are also being classified also. Each series have a subclass of NumPy array. Okay, each series have data type, any data type. Each series has an index label. Each series have your duplicate value or the functionalities or object classes. Okay, now if your like index labels does not have any order list, okay, or order, we can say the order subclass also, or the data also. These all are being possible with a duplicate value. Suppose if I don't have any value of A is equals to Z, if it's just a blank. So the obviously this value would be equals to 0. The duplicate value. Okay, now duplicate value doesn't mean like you are being suggesting it many ways. No, it stands for like if you are being having or not, that depends upon. Okay, now if you just remember, series have a subclass of NumPy. Series have data type. Series have index label, which doesn't need to be order or anything. See, like I can give the value of A as 6. Okay, which I have to define in that. Suppose in this example, if I don't need 2 as my F or 4 as my A, I can rearrange it. Okay, before giving this value, I'll rearrange over here only. Okay, now each of the value like A can be 6, B can be -5, D can be 6.5. And each of your values can have any of your data type, whether it's int, whether it's float, whether it's complex, real number, or imaginary number. Okay, each of the data type is admitted. Each subclasses are there, index labels are there, and duplicate value means like you can given the imaginary value also. Now, what happened when you're while you're indexing your series? Okay, just think of like if your series are being fixed length or order dictionaries. Like if your values are being not given as a fixed length or any of that, that doesn't mean like your item have a unique value or your item has a propagating value. Okay. Now, if it doesn't have or it is not be able to configure out, that depends upon you. Okay. Now, if you're not attaining the value, the pairs of your column, okay, suppose over here, I just attained only one of the column in here. I didn't give the end of this bracket. This will not give me a proper output. It will be giving me the error, obviously. And tuples, we don't need any parenthesis. That is completely optional. But in series and every of your data type, it's like obviously compulsory. Over here also, if I am not giving, this is the program for compiling the series up to range of 4. Okay, now up to 4, I didn't find that up to 4 means like I am not including 0. I'm not including 4. That means obviously from the 0. If I have a condition for I in the range and I is greater than equals to 0 or 1, that it will be not counting my 0. And the list is AB. AB means AB means like A, the singular, the B, the singular, A again singular, B again singular. Now, again, I am printing the list of my S2 configuration, that is 0, 1, 2, 3, indexing in value. Again, if I have to get the print of the value of A, the value of A is been 0, but that is my wish, like if I'll be attaining the value of 4 or not, like I'll be assigning that value or not. Then again, if I'll be getting the value of S2, the value of S is different than S2. S is being defined with a proper series. S2 has not been given there because it is S means like it is a range of it. How much the range is being proper. But S2 means like what the list you have been defined furtherly in your program. Okay. While again moving to what are the operations of your series, there are two types of your operation in your series, that is filtering, again your NumPy type operations on your data. Now when you are being filtering it, okay, now when you are being going to filter that all the list, all the problems of your the particular arrays, the particular the list of your arrays, that is being given by the first of all the filtering over here. And if the condition you apply that my S is greater than 4, it will execute more. Now, S is equals to or equals to 4. That means like the value of S, like the value of this is greater than 4 or not. If it's greater than, it will execute. Like C and E has a greater value, that is 6 or 8. Okay. Now, again, if I have to just write the value of the like S as in a Boolean expression. Okay. Now, in the Boolean expression FACE. Now I have to see like my value has been greater than 4 or not, the range I have mentioned above. So 2 is not equal greater than 4, then it's 4. 4 is not greater than 4, it is just equal. Then again 4, it's false. Then 6 is greater than 4, that is true. Then 8 is greater than 4, then again it's true. Okay. Now each of your value depends upon the range you have defined. Now range you define, that means like how your ranging is being configurable with the proper agents in that. Now in this series we have the agents purpose. So agents purpose means if your range is being confined, if your range is being determined or not. Okay. Well, moving forward to that, if I have to multiply it, okay, now I have to multiply each of my term with 2. Okay, so each of my term will be multiplying with the 2. Now phase is your indexing and value both are there. Now if I have to, S is this only. Okay, and if I have to print the way get a multiplier is every value of my S with 2, it will be giving me 2 2s are 4, 2 8s 2 4s are 8, then again 6 2s are 12, 8 2s are 16. Okay, now the value has been configured. These are the syntax how you write the proper the orientations of your the program and your printing of your importing of in your pandas. Okay. Now what happened when your data has been incomplete in your series? Okay, now your data has been incomplete in your series. That will accommodate your incomplete data. What happened in your tuples? What happened in your NumPy? Data types, that doesn't allow, like they didn't allow us to access, delete, remove, or any of it. Okay, but what happened in your series, it allows us to like accommodate more often your incomplete sentence or data in that. Suppose my data is now, what is this is the dictionary. Okay, now it have the key plus value, again key, again value. Now B is equals to 100, C 150, D 200. This is all the dictionary values and data types are being used. Okay. Now I have to assign the value in my series of my data S data. That is S data means like it is the value defined. Now if I have to get the series of my S, each value has a key. We studied about that in the dictionary. We read about like in each dictionary. First of all, the point to remember it, that it is being in your curly brackets. Second, it has been it has the key and values, the pairs of that. Third, your key is been in your columns, in the apostrophe. Okay, commas in that. So while writing like this, like each of my data is being structured like this. While writing like this, we can write the dictionary also simply. We know each key is equal to value. The key is value, then key and value. These are in pairs. So B is 100. Now here, the simplest the execution will be taking place. The B is 100, C is 150, D is 200. Then series, if I have to add that series with the data, and or add the value of the list in that as an A, B, C, D with a sequential. Okay, I have to read about the A, B, C, D. Just forget these values because this is not now available to the starting point. Okay, these series are being given either as a non-value or again present as standard value in the list, because we know A haven't have like the value which is being predefined in that, so obviously we have to write that also. So like none means like we can give it zero also, null value also. Again, similarly with the last program, we did the multiplications of the two with the value assigned with your dictionaries or the value data is there. So B multiplying with 100, that is 200, then 150, 300, the 200. Okay, these are the value it will be giving us an accommodation. Now, why we use the automatic alignment? So in your series, we know like we have the columns also, we have the deletions also. For label based functionalities, we used to get the series with more oftenly the automatically alignment. Okay, now for automatically alignment, we generally used to see the what values are there. We know like in NumPy, we generally used to get that array or non-array with the proper sequence. Okay, now proper sequence we have to judge out. Now what happens if you don't have the proper array to be judged out completely, or can automatically be aligned to that. Okay, now aligning that more oftenly the series in that, we can use a furthermore concepts, that is like if I have to get that all the values, all the series values. Okay, it's like 1, 2, 3 index, we have CBA. Now indexing will be charged to this CBA and the series will charge to this 1, 2, 3. Again, with the last program, we were having the value of index the series was the 100, 150, and 200, and we gave the value of A as a numpy, null type. Okay, now if I have to combine my S also and my S2 also, we know A multiplied by A, that will be 0. Then again S2 will be dividing to the E, there's 200, 150. Okay, now why D is being none? So coming forward to that, when we combine the D as a structural part of the series and index, this all came under the variable formation of your dictionaries. Either it will execute the dictionaries, either it will be going to give your list. Got my point? Now, moving forward to the most interesting part of your Pandas module frameworks, that is data frame. In NumPy, arrays are like data frames, just like the NumPy arrays, a data frame are also there. Each column can have a different data type. Okay, each row and column can be indexed. Each size can be mutable. That means we can insert it, we can delete it, we can columnize it. Okay, now in data frame, object for data manipulation with the integration indexing is there. Then tools for reading and writing data between in-memory data constructions are being there. There's a different type of file formats are there. Then the data alignment and data integrating is being missing in your data frames. Okay, as compared to the NumPy, we have that, but in data frame we don't have. Okay, now reshaping and pivoting of a data set can be obtained. The label-based slicing and fancy indexing and subsetting of a large data set can be there. Until or unless you are not being suitable, cannot be advisable, you cannot do. Now, similarly, in this of the diagram, you can see like we have a columns, we have a rows. Now, indexing are being done up to E bar, A, B, C, D, E. Now, each of your that column has been configurable by the different types of your data type. Okay, now is it foo? It is bar. That is bar just an alphabet of that. Then foo is just the value just being configurable. Then bars can be obtained by the the point part also, that is we can call that's a float also. Then question, that is this boolean also, like the boolean we used to write that is true, false, or true. In this we used to write the qua. Okay, now while importing, while like inserting or removing that, we don't know how we can do that, but we can structure that as in the columns we have. Each variable of the A is been structured with the columns, that is 0, x, 2.7, and true. These are only and only we can insert also, we can delete also by column, not just randomly. Now, what happened when we used to get that data frame in a spreadsheets? Okay, now getting that all the data structures in a data frame in our spreadsheets, we need to get that the data containing an ordered collection of your column. Okay, not an on always remember your data should always be getting to the ordered collection. Okay, each of your data frame has column, each of your data frame has a row, both are there in your indexing. Okay, while configuring out the dictionary part or dictionary absence, these cannot be just kept out. Now, what happened when you create? Now, while like when you do the label based slicing or your fancy indexing or your subsetting of your large data set, each of your data structure has a column for deletion or assertion. There is the group by group assertion or group by group allowing of your split array in your couple of combining of your operations on the data set. Okay, now creations of your data set, data frame in your equal length list. Now I need an equal length list. Suppose if I just state that configured out that my state is there, air, then doesn't popping out. Okay, now state FL, FL, GA, GA, GA. Okay, just a random part. Air 2010, 2011, 12, then 28, 10, 11. Okay, now the dating has been done. The date, the pop are being. Now what happened when I'll print this data frame is in data. Okay, and create this data with the equal lengths in the list. So equal lengths in the list means like each of the value has been given whether randomly, not for the randomly, but it is for the creation of your equal length by merging and joining it. Okay, by allowing a combining of all the operation like 0 pop has been given by 18.8. Now in 18.8 we have FN, we have 2010. In 19.1 we have 2011 with FL. Each of these value are being given the equal length of our list. Now moving forward to again what are the creation with the dictionaries. Now again the dictionary of dicts are there. The each value in dictionary we know each value has a key and each key has a value. Okay. Now if I'll be just configuring out that my state is there, FL is just like 2010, 18. Then it is a key, it is a value, it is a key and it is a value. Now I need the pop data only. Now the pop data only that will be 2008, 2010, 11. That is just a series of it. Now FL is been given with a value of NL, that is NaN and 9.7. Now if your value is already been there, the value cannot be executed with a text bar. Okay. What happened when you like while you're doing the data setting or data merging or data joining, there is one point to remember that every time the hierarchical X is indexing to work with the dimensional data, with the lower dimensional data is occurring. Okay. Whenever you use the columns, whenever you have been using the retrieving columns as a series, always remember 2 points, that is dictionary notation and the attribute notation. Every row can be retrieved by the position, every row can be retrieved by the name, and it can be given as a value of ix attributes. Now, what happens when ix attribute are being used? Every hierarchical access or every indexing to work with the high dimensional data, the lower dimensional data structure, these all have the merging option, they all having the joining option, then grouping of your engine splitting, applying of your engine splitting, these all are being there. Okay, suppose I just need a state name. Okay, now state name already being defined in the previous program with FL, and GA. The state name, it will be giving on its index, on its value. Now, if I just need a name of my state, Again, with a pop, air, both, I have to just reframe my data. I have to get the reframing of my data in a previous concept, and then I have to just land that data. Okay. Now, when we use the data loading, that is very, very critical. That is very critical point to just remember about the data loading and data happening. These all are the points which are being important to that. So when you do the data loading or when you start the data loading, okay, just remember that always handle that data with the support of pandas, and data holding will be always being supported by the data actual data holdings. Okay, now how to read that or how the text file in data happens. First of all, just read for reading the CSV file, just write upon the syntax that is read CSV, okay, underscore CSV, then reads table. Now you have to read the table, or you have to make the table in CSV part. Just write that, because without that you won't be able to get. If you are not able to get, there's no way to read the data also. Then if you are not writing this, in writing your data, this all are being structured out the this part. Okay, now the structured data we did about the what is structured data and what is unstructured data. The structure with the structure we have in our the data first slides, that was just to remember about the data that has been converted in the proper execution with the suitable time, with the data raw data execution with the processor, and everything, and the vice versa of your unstructured. Okay, now what happened when you have the Excel parts or when you have the proper packages of all the data you have? This, all your data depends upon your Excel RD, the OpenPy Excel packages, and there are one more than the Quintel TX. Okay, so these all are being depending on the Excel timings you have been using for the database. Actually, the more like SQL module is the best for reading your frames. Now, what happens when you use a data frame? Time series functionalities as being the properly the most important. Your date range generation or your frequency conversation or your moving window statics, both are being depending upon the what your moving windows are being giving as a linear regression, your date shifting, your date lagging, time lagging, and there are many more. For providing all these functionalities and everything, just remember you should filter your data. You can define that data. You can configure that data with your upcoming paths. Okay, the libraries are simply and highly optimized for all your performance with the critical code parts you have been writing over there or you have been configuring that all depends upon. Okay, now for plotting part, like I'll give you one more one of the most of the data frames, that is just to remember that the Python is mostly used the data analysis. Pandas allows us to import data for various functions, that is file formatting, there is a comma separate the functional attributes, your data frames, your series, your functional requirements and everything. Okay, this all allows us for importing the data from various file formats such as the comma separated value, JSON files, SQL files, Microsoft Excel, and many more are there. So Pandas always allows us to perform the various data manipulations operations, which is merging, then it is reshaping, selecting, as well as the data cleaning also. The data wrangling feature we read about, the data wrangling now, like previous slides and that. So what happened when you have been using this all the function as in data finding and data wrangling? This is the most point occurs that how to plot your data frames, your data points, in any of that. For that, just remember you are being plotting that data. Now, if I have a data to be plotted as a variable, I will sum that all the days, all the x's have been done. Now, if I write the size that is under the day, size is up to 6. Now, the day is Friday, Saturday, Sunday, and Thursday. Now, if I have to add this all the days in the singular part, and this will be executing first of all to 1, then 2, then 3, 4, 5, 6. It will not automatically shift to 1 plus 5. No, it will be going to the sequence part. 1 to the 2 and 2 then 3. Okay, now if I have to add it the series part, that if I have to only add one series with each of every day, Friday, Saturday, Sunday, Thursday. Okay, if I have to add it all the series with only one axis and I have to backstack that, or I have to time bar that, or I have to start that in a true or false value. This all are being doing as a plotting function that is held by the matplotlib access. Now here we will be reading about the matplotlib access. Don't worry about that. Then we are going to shift about the plotting like Friday, Saturday, Sunday, and Thursday. Now what happens when we are using the only the part 1 of our plannings of the Friday? Okay, so it is 0.05. Starting from 0.05, that is will be up to raising some of the point in that. Now, why the line 2 is being highest than 0.05? Because we have defined the variable as 0, 0.2, 4, 6, and 8. Okay, now the gap difference between that is the 0.2 or 0. Approx to that. Now, when we are going to do so, we are shifting that all the values in the particular form. Again, shifted to the similar for the Saturday. Again, the plotting for that. See, if you have been getting some problem also in your plotting your graphs, your pie graphs, or any of that, or your values are not being executing properly. This is the major benefit in your graphs representation on your statistical analysis of your representation of your data. Because if you're not getting a proper data, there can be a minute errors in that, which is very negotiable. We cannot judge it out because in bar graphs we get some of the errors like pointing like 0.01 also the error is there. So that is completely negotiable because sometimes what happens, the computer is being executing on different parts in it. But in this, it is actually being occurring as a, like suppose I got an error, like I wrote 200 lines of code. Okay, and now the point is the execution of my programs. Okay, now if my execution of programs is there, now I find it in the second part or the second size, in the Friday part, I have an execution of 0.84. Now, if it is occurs like only 0.6, now I know in the representation of this that this part is wrong. I'll immediately go to that point and like I know that where point is. I immediately will going to that point and judge out like where the execution is being going wrong. This will be easy because if you don't know that where the, if you just look after the simplest of your output or everything, you don't know how to do so. Just remembering like how the program is being executed with the stimulus path. Okay, that's what your bar graphs are being executed for. Now again, there is a representation of bar graph. Now for the bar graph, you just have representations of the major aspects. Okay, so major aspects means like it is being given as a bar graph. In the previous classes also, we have made of bar graphs, pie graphs, and everything. So this is the what the plotting is being done in the matplotlib. Now, what happens when we use to index that axis, or what special pandas is being addition of a flavored sauce to our project, to our learning, because it enables our free alignment of programming. Second, it prevents major source of your data munging and that frustrations and errors. That errors are the big frustrations itself, but still it is not being casted as. But your data munging will obtain your the further the errors in the frustrations and that. Third, it has the fastest data selections and it has the fastest data sections also. Fourth, it is a very powerful way of describing the shape, joining, merging, and pivot table operations. A very good way to do that. Just remember of your 3 points, that is 4 points, that is reshape, join, merge, pivot table operation. If you get the errors in that, okay, or you have to describe your programs. Now, what happens when you do the data alignment? Okay, now data alignment, when you do, you have the objections of operations that have to join it. For joining it, E1, C2, it's 2, 4, okay, and D3, E4. Again, I have to plus it. Now, what happens if I have to plus that elements in that? It is not going to be get that to the multiplication of A plus B, then B plus 0, and any of that. Okay, it will be giving me the value where the value is not being added. Suppose in this, the value is not being added as a, no, A, B, C, D, E is not there. E will be entered. Now, 0, 1, 2, 3 is there. Okay, now what happens when we add it? It will be given to the 2 plus 0, it's 2, then 4, then 6. Okay, just combining this one. 2, it's 2, then it's 4, then it's 6. Now we don't have a space for 4. No, we don't have any space for 4, so it will be getting as an error. An error will be written as the NA, that is null value. Again, for the 0, it doesn't have any value. That is again and then NA, that is the null value. Now, what happens if we do the same structure by the group by? For group by, split, then we have to join, merge, apply, and combine. Okay, this is the key value. This is the splitting part. In the key value, we split up to combining A, again classified B, again classified as C. Split that. All the function we have split it. Now again, A value we are having in the reference of 0. Again, A value is 5. Again, A value is 10. And B similar 5. Again, B similar 10. Again, B similar 15. We splitted this, we will be taking the value also and index also. In the C, we have 10, 15, and 20. Now we have to do the sum of each and everything. Now for doing the sum, like doing individual sum of adding of your all the values, we will be configuring of this, taking each and every value of that. Like A, the sum of A is 15, B is it's 30, C is 45. Okay, while writing each and every value again and again, we can give that a single value to the sum of that. Like if I'll be writing A is equals to 15, again 3 times A I'll be writing, that will be not a good code. Now we have to combine all the classification we did according to the value. Okay, now according to the value it is 15, then 30, then 45. It is giving me the value of all the value that is 15, 30, and 45. Okay, now moving forward to that is hierarchical indexes. And the hierarchical indexes, we know that we also read in the data frames also. But the hierarchical indexes, that is to work with a high dimensional data in the lower dimension data structure. First of all, it should be cinematics. Then it should be enable easy group. Then terminology should be there. Then the natural part should be there. Okay, now these all the points should be same with the proper advantages. A is 1, 2, 3, B is 1, 2, 3, 4. These all are having the natural part, but the reshaping of that all has been given is a multiple level. I hope it has been clear to you all. This is up to that till the hierarchical indexes. Any doubts to anyone?
Hey guys, are there any doubts till now? If you guys have any doubts, please, this is the right time to talk. Yeah, we will wait for a couple of minutes. Yeah, let's wait for 5 minutes. Let's see if anybody has any doubts.
Hello.
Hello, Ashika, are you able to hear me?
Any doubt to anyone?
Hey guys, if there are no doubts, probably let's wrap up the session. If you guys have any doubts, you can just drop an email to our email ID. Okay, and also you can just WhatsApp us. In any case, probably we will take up all the other interesting aspects, including assignments and some code during the next sessions. Yeah. Okay. Thank you. Thank you very much, Ashika. Have a good day. Thank you, guys. Thank you. Good day. Bye.